So, like I said, today we're going to be doing 16.1, which is trigonometric functions in right triangles. A lot of the information here, it's like a kind of a dump of information at first. We're going to reference this stuff throughout the section. But essentially what you need to know, mainly here for this particular section, is when you're dealing with a right triangle, we have an angle theta. Okay, that's our reference angle. That's either the angle that you're trying to solve for or the angle that you're given information about. In a right triangle, you always have two other acute angles because, of course, if the one angle is 90, there's only room for the other two to be acute. Now, the angle across from the 90 degrees is always the hypotenuse. The angle across from theta, or the side across from theta, is the opposite side. And then adjacent is the one that's directly next to the angle. Okay? Is that you?
No, that's him.
Can you not?
I don't have it. You have it.
Whatever one of you it is. So, when we're dealing with a unit circle, we're going to use r instead of hypotenuse, but we'll talk more about that when we get to that point. Now, here are the trigonometric function rules. You guys remember SOHCAHTOA, hopefully? So, in case you don't know, you can add it somewhere if you want, but SOHCAHTOA is because sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. So it's a little mnemonic device to memorize that rule. Okay? So that's what the rules are here. Now we're also going to start introducing the reciprocal trig functions, cosecant, secant, and cotangent, but not too much today. And then lastly, we have 30, 60, 90 triangles. And 45, 45s. You use these a lot in geometry. One of the biggest topics you do in there. Do you guys remember this?
Yeah.
All right, we'll talk a little bit about that today. And then lastly, of course, everybody knows Pythagorean theorem. Pythagorean theorem can be used to find a missing side of a right triangle, given you have the other two sides. All right. So what we're going to start with is practice using Pythagorean theorem. So in order to use Pythagorean theorem, we're going to do the two legs squared, added together and equal to the hypotenuse squared. Now the side that is on the equal sign on the right, just alone, always has to be the hypotenuse. You can identify the hypotenuse because it's always directly across from the 90-degree angle. So this would be 25 plus 144. 169 equals x squared. We square root both sides. Luckily for us, 169 is a perfect square, so it gives us 13. Any questions about that? All right. Next one. We're no longer solving for the hypotenuse. We're solving for one of the, the legs. So x squared plus 7 squared equals what? 14 squared. That's x squared plus 49 equals 196. We subtract 49 on both sides. That gives us x squared equals 147. Now, in this class, mostly, you're going to have a mixture of both, but we're going to leave everything in what we call simplest radical form. So x equals, we're not going to get it as a decimal approximation. We're going to break down the radicals. You guys remember doing that? So square root of 147 can be broken up into the square root of 49 times the square root of 3. Because 49 times 3 is 147. So everybody see what I did there? I rewrote it as a product of two things that equal that thing. Now, why would I rewrite it as 49 times 3? Yeah, 49 is a perfect square, right? So my answer here is 7 radical 3. So any questions about that? Okay. Now we're going to get into using actual trigonometry here to solve some of these. So for the first one, here's what you're going to do. We're trying to find a missing side length, and you're going to have to be given an angle and another side to do this. So what you're going to do is you're going to identify the angle that you're given. From the angle that you're given, you're going to identify two things. The item of information you want to know and the information you do know. So the side that we do know, is it opposite, adjacent, or hypotenuse? Opposite. The side that you want to know, what is it? Hypotenuse. You can always find the hypotenuse because it's always across from the the right angle, the 90-degree angle. So everybody good with how I identified that? Now, what trigonometric function uses opposite and hypotenuse? Sine. So sine of the angle measure is equal to opposite over hypotenuse. Now, to solve this equation, I can put this over 1 to make it into a fraction. And then anyone remember what I can do here? Cross multiply. Which will give me x times sine of 60 degrees is equal to 22. And then if I want to solve for x, what should I do? Divide by sine of 60. So in my calculator, x is approximately equal to, what'd you get? 25.4. Okay. Let's check. 25.4 is correct. I trust you, I just have to double check. Alright, any questions about that? So just be on the lookout for what you're asked to round to. Sometimes it's whole number, sometimes it's 1 decimal, etc. Okay? Alright, moving on to the next one. Step 1 is I'm going to identify the angle they give me. And then I have the opposite. And what would be the 6? Adjacent. So what trigonometric function uses those two? Tangent. So tan of 52 degrees is equal to opposite over adjacent. We're going to put our tan over 1, and then we're going to cross multiply. That gives me x equals 6 times tan of 52, which means x is approximately equal to 7.7-ish. And this is not a degree measure. We just found a side, so don't put degrees on it, okay? Everybody good with that? Okay, next one. So this one, I have the angle. Now, what is x? What side is that going to be?
Hypotenuse.
Good, and the 7 is going to be?
Adjacent.
Adjacent. So what trig function? Cosine. Cosine of the angle measure is equal to adjacent over hypotenuse. I put this over 1 and I cross multiply. That's going to give me x times cos of 33 degrees is equal to 7. I divide both sides by cosine of 33, which gives me x, go ahead, 8.3. So the hypotenuse is approximately equal to 8.3. Now, what if I did the calculation and the hypotenuse came out to be 5.3? Would that be possible here? No, why not? Hypotenuse has to be the biggest. So that's a good way to kind of check your calculations, make sure they are right, based on just using logic of what we know about triangles, okay? All right. Now we're going to look at finding a missing angle, okay? If you want to add a little tip to yourself here, whenever you're finding a missing angle, you use the inverse, okay? If you're trying to find an angle, you always use the inverse. That's the only time you do it, is when you're finding a missing angle. Okay. Missing angle is when you use the inverse. So that's when you're going to use the second button on the calculator. So let's talk about it. So when we're trying to find a missing angle, I keep clicking up. It just keeps bouncing up to the top. I don't know why. So you're going to identify the angle that you want to know. Okay, step 1. Step 2 is to identify the two information pieces you have about the sides. What's this one going to be to the angle? Good, and this one over here is the adjacent. So what trig function? Tangent. So tan of angle is equal to opposite over adjacent. Now what you always want to know is with a regular plain trig function, tan, sine, cosine, inside of that function is always an angle measure. Now, if you need to solve for that angle measure instead of the other way around, you use what's called the inverse. The inverse allows you to flip what it's equal to with what it's of, okay, to allow you to solve for x. And that's a separate calculator operation. So, x is approximately equal to. On your calculator, I think it's the same for the other calculators as well, but do you see where the tan button is? Do you see in the highlighted green, the second option, it says tan with that -1 symbol on it? That's the one you want to use. So second tan, and then 15 divided by 8. Don't forget to close the parentheses there. And when you do the math, can maybe tell me what you got? 61.9. Good, so we're going to round it. My pen is acting up today, I don't know why. But yeah, it's going to be about 62 degrees. Did everybody get 62? Alright, if anybody's having issues with calculator, just let me know. I'll come around at the end and help everybody out if you're stuck. Alright, so the next one. And if you wanted to, you could do regular tan of 62 and make sure it's about 15/8 to check your work. So for the next one, with the angle that we're asked about, what is the 6? And what is this 14? Which means we're going to use sine. So we're going to have to use the inverse to solve for x. So we got second sine of 6 divided by 14. And if you did the math correctly, you should get about 25 degrees. Everybody got that? Alright, and then the last one here, of course we're probably going to use the one we haven't used yet, which is cosine, because this is adjacent and this is hypotenuse, which means we're going to use cosine. I don't know why I'm writing tan, because it's definitely cosine. Cosine of x is equal to adjacent over hypotenuse. Now we have to flip these so I can solve for it. So it's going to be cosine of inverse of 6/16 is equal to x, which means x is approximately equal to, good, 68 degrees. Now another red flag is if you get an answer bigger than 90, a triangle cannot have more than 190, anything bigger than 90, right? Because that would be two angles over 90 would go over the sum of the triangle, which has to be 180, right? And there'd be nothing left for the third angle of the triangle. Does that make sense? All right. So now we're going to talk about 45/45s and 30/60/90s. Now the cool thing about these types of triangles is when you have a 30/60/90 or a 45/45/90, you can always get an exact answer. That means that you don't have to do any rounding. You don't have to use the calculator, but you can use the calculator to check your work like we did in the previous ones if you want to. So with a 45/45/90, here's how the setup is always going to be. The two legs, because they are isosceles, it's a right isosceles, they're the same, you're always going to call these L. And then the hypotenuse is always whatever L is times radical 2. That's the rule for the 45/45/90. So, if I know that this side is 8, what does that mean this side must also be?
8.
And I know then this side must be 8 radical 2. It's just whatever the other side is times radical 2. Make sense? All right. Now over here, we know that the two legs are L, which means this is L radical 2. So since I know what L is, I can just plug it in. I can plug L into this formula right here and get what that side is, right? So this side would just be equal to 5 radical 6 times what? Radical 2, which gives me 5 radical 12. What can I break up radical 12 into? Good, radical 4 times radical 3. What is the square root of 4? What's 2 times 5? So the answer is 10 radical 3. All right. Now here, they give me, not L, but they give me L radical 2. These are L. So in order to solve for the other two sides, I need to find what L is. How can I solve for L in this equation here?
Divide by radical 2.
Good. You can divide radicals into radicals, so what does L become? Radical 3. And you could check your work by multiplying both these by radical 2 and making sure it equals radical 6. Okay. So now we're going to move on to the 30, 60, 90s. So these have a different rule. The 30, 60, 90, the 30 is your L. The side across from the 60 is your L radical 3. And the side across from the hypotenuse is 2L with these ones. Okay, so you do have to know those rules, however you want to interpret them and use them. Sometimes they use X. I personally don't like to use X because if they use X as a variable, it's like two different X's and that can be confusing. So you're always going to have information about one of the sides and then solve for L, of course. So how could I solve for L with the side that's given to me? So what is that going to come out to be? 2 radical 3, right? Which means that I now know what this side is, correct? It's always half. The cool thing about the 30, 60, 90 is the hypotenuse is always double the side across from the 30, and the side across from the 60 is always radical 3 times whatever the side is. So now if I want to find this side, what do I have to do? Multiply by radical 3. I take L and multiply it by radical 3. That gives me 2 radical 9, which reduces to what? Or simplifies to 6, because that's radical 3, or square root of 9 is 3, 3 times 2 is 6. So this side here is 6. Bless you. So it takes a little bit to get the hang of, but they're not too bad. First thing we're going to do is we're going to set up our L's on this one. So this side's going to be L. What's this one here going to be? Good, and this one's going to be 2L. So if one of them has a numerical value, bless you, you can set it equal to whatever your L expression is. So in this case, what would L be? 5. For anybody wondering, we just divided both sides by 2 to get L, which means this side here has to be what? 5 radical 3. It's just L times radical 3. This one over here, this is L. This is L radical 3. And this is 2L. So this one would be pretty easy. We have L. L times 2 is just 2 times radical 6, which is just 2 radical 6. Can't do anything with that. So that's going to be your hypotenuse. Now as for this one, we're going to end up with radical 6 times radical 3, which is what? Which I can break down into. Good. And why would I want to do that? 9's a perfect square, so my answer is 3 radical 2. This side. So any questions about that procedure? Now what I was trying to explain to you guys is this unit is a little different. It's not like the usual homework notes. We're going to have activities.